Welcome back, grade 8. In this video, we're going to be continuing to talk about polygons, but instead of talking about interior angles, we're going to start talking about exterior angles. So if we think about kind of a four-sided shape, we talked about how we could figure the interior angles that are here. But we can also figure out exterior angles. So let's say I continue to line here. This would be an exterior angle. If I continue, that would be another exterior angle. Let's call that X. Let's call that Y. This would be, let's call it Z. This would be one. Let's call that W. So we have all these different exterior angles as well, which continue beyond or past the particular shape. What's interesting about exterior angles, the sum of exterior angles here, is that no matter what the shape, no matter how many sides it has, if we add up all of these exterior angles together, they all equal 360 degrees. Always. No matter how many sides we have on the shape, it's going to equal 360 degrees. So, the sum of the exterior angles is 360 degrees, always. We're going to use that bit of information. And that's really all that there is in terms of a lesson for this piece. A lot of it comes through now the examples and the practice of all of it too. So we are going to step into the examples. If you'd like to follow along, feel free. Using that information, we're going to figure out some of our exterior angles, as well as using some of our previous knowledge about interior angles to solve for what's missing in different sided shapes, in different sided polygons. So let's start taking a look. We're going to take a look at example 18, 19, and 20 through the rest of this section on polygons. Example 18. Example 18 gives us quite a shape here. Let's see if we can draw at least most of what's here. We're given information that this is our Y, that's what we need to solve. This is our X, that's also what we need to solve. This is 89 degrees, this is 102 degrees, and this is 103 degrees. Okay, using these bits of information, we now need to solve for what's left. We now need to solve for the rest of this particular question. So we know that X here, that's the first one that we can solve. If this is a straight line, then this has to equal 180. So 180 degrees minus 89 degrees is going to give us our X value, which in this case, when we go through, would be 91 degrees. It's what's left. That's our X. That was hopefully our easier one. Now the only thing left to do is figure out our Y. Now that we know that X is 91 degrees, that's our exterior angle. We know that the sum of all exterior angles equals 360. So we have 1, 2, 3 exterior angles. Just need the fourth. So in other words, 360 degrees, that's our total, minus 103 degrees, minus 102 degrees, minus our new 91 degrees is going to give us whatever is left for that particular Y value, which when I plug all of these things in, 360 minus 103 minus 102 minus 91, I'm left off with 64 degrees for my Y value, using my sum of exterior angles, as well as my knowledge about complementary angles there too with that straight line. All right, there's example 18. Let's step into example 19. Example 19 tells us, it says, find the measure of each interior angle of a regular decagon. Okay, so we're back to our interior angles. We have a decagon here, and it's a regular decagon, which means all the angles are going to be the same. So first things first, we need to figure out a decagon means that it has 10 sides. Using that information, we now need to figure out the sum of all the interior angles. Well, remember that the sum of interior angles equals n minus 2 times 180 degrees. In other words, our n, our amount of sides, is 10 minus 2 times 180, or 8 times 180 degrees, which equals a sum of interior angles of 1,440 degrees. Because it is a regular decagon, all I need to do is divide that by 10 to figure out that each interior angle is 144 degrees. That's one way that we could particularly solve this question. Another way that we could solve this particular question is we could say that there's 10 sides. They're all going to be the same. The outside angles have to equal 360 degrees. So if the outside angles measure 360 degrees, I have to have 10 of them. Divide that by 10. Each exterior angle is 36 degrees. Now, the exterior angle plus the interior angle together have to equal 180. It's a straight line as it continues past. So 180 degrees minus 36 degrees gives me 144 degrees for each interior angle as well. You can kind of think of this as a method 1 and a method 2. There are two different ways to solve for the interior angles of that particular regular decagon. So that's example 19. Now let's go to example 20. In example number 20, we're told if each interior angle, so we're given the interior angle, of a regular n-sided polygon is 150 degrees, find the value of n. Okay, so we need to figure out the amount of sides for this particular shape. We know that interior angle equals 150. Now this isn't the sum of the interior angles, this is just an individual one. And so we need to kind of figure this out from here. There's two ways to figure this out. There's kind of like a method 1 and a method 2. Method 1 is probably a little bit more challenging. Our sum of interior angles we know is going to be, 150 is the interior angles times n, however many sides, however many angles they're going to be, which is equal to the number of sides. And so that's going to be equal to our formula, n minus 2 times 180. We're going to have to use this in order to solve the rest of this question. So 150n equals, let's do distributive property here, 180n minus 360. Okay, now let's move things around here as much as we can. So let's move the 150 to this side, it becomes a minus 150. Let's move the 360 here, it becomes a plus 360. So 360 equals 180n minus 150n, or 360 equals 30n. Divide by 30, divide by 30, and I figure out that n equals 360 divided by 30, which is a 12-sided shape. That's one way of solving that. I would probably say that's the more complicated way of doing it. The other way of doing it is thinking about an interior angle is 150 degrees, which means when that makes a straight line, that the exterior part of that must be the extra 30 degrees. If interior is 150, exterior must be 30, because together they have to equal 180 degrees. Okay, if the exterior angle is 30 degrees, how many of those do I need to get 360? Well, that's what I need to figure out. 30 times n equals 360 degrees. Divide by 30, divide by 30, my amount of angles that I must have, which is now going to be the same as the amount of side lengths, is going to be 360 divided by 30, or 12 as well. So you can think of it method 1, method 2, two different ways where we could figure out the amount of sides in a regular shape using only one interior angle. Hopefully that helps as you step through, try it 18, 19, and 20.